Welcome to 1.7, List Data Structures. We're going to start this lesson with a discussion about tuples, and we're going to look at enumerate, and then we're going to look at our data structures. Alright, let's dive in. So what's a tuple? Well, a tuple is just a list that is immutable. In other words, you cannot change any of the elements inside the list once they're made. And they are assigned with commas and optionally parentheses. So I don't know if you've ever tried this before, but let's try this together. So we'll type T equals 1, 2, 3, 4, 5 and comma 5, 4, 3, 2, 1 and then the string hello. And now let's print T of 0. Notice how T became a list, right? So the element at 0 is 1, 2, 3, 4, 5. Let's actually just print T, and you'll see that we have a tuple. Okay? So when you assign a bunch of things with commas to a variable, you are creating a tuple. Okay? And so this is our tuple here that's stored in T, and all three of these things cannot be changed. Now to test this, let's just try appending something to T. So we type t.append, which normally would add, right, whatever we type here. We'll type the number 10. You'll notice that it says, hey, tuple object has no attribute append, because you can't add anything to a tuple. Once it's created, it is set in stone. It's like a constant, really, right? Variables are variables that we make. These can change, but if you type something like difficulty, right, a constant in capitals, you set it to 10, then technically this should never change because it's a constant. So a tuple is the same type idea. So while you can't add or remove any items or elements from a tuple, you can add a mutable object to a tuple. So for example, let's say that we have G equals the list 1, 2, 3. And we have U, which is the tuple. We'll set this equal to the tuple 1, comma, G. So it's going to have two things. It's going to have the number 1 and this list G as its second element, right? So here you can see it. We have 1 and our list. Now, what if we were to change something that's inside G? Well, we could say G of 0, right, the first element. Let's change that to a 5. Right, now let's have a look at G. You can see it contains 5, 2, and 3. And now let's look at U. And so you can see because U contains 1 and G, right, this is actually a reference to G, this thing that it contains. And G changed when we set its first element to 5. And so this is reflected, right, in U because it contains G. So now, because tuples can't be changed, they make great candidates for holding lists of constants. So if you have three guys and you want to make these 3 guys are workers, for example, and we just want this to always be the same, and these 3 guys, we're never going to change them, then you could say, you could set this to workers. We'll set, just copy paste this in here. And now we have, right, if we type workers in caps, this is a constant. We have John, Jake, and Fred, and now we cannot use any of these methods that we're used to. Like we can't do workers.pop, right? It's going to complain because there's no attribute for a tuple to remove an item. This cannot change. But the nice thing is that we can work with these just like a list in other ways. We can iterate through them because they're iterable. So we can say something like for dude in workers, right? And press tab and we could print dude. So this should show us a list of all the guys inside workers, which we know is John, Jake, and Fred. Now, these things, okay, John, Jake, and Fred, all these elements are indexed the same way as lists. They start from 0, okay? And any data types really that do this in Python have another name. They're called sequences, okay? So this is kind of a general term to describe both lists and tuples. Okay, next we're going to look at enumerates. All right, let's grab this little list of good pets, which you guys have seen before. Paste this in here and stick this in memory in the variable good pets. Okay, now recall the range object that we've used frequency, right? Recall this when we're iterating. We often use this to tell, right, to state how many times we want to go through a loop, right? And this was a good handy way to give us a counter that increased until some number x, okay, in range x. So when iterating through a member, right, the members of an object, like a range object or something, we've also used lists like this, right, for animal and good pets do action. So if we wanted to loop through this and say print each of these or do something with these strings, we could use this type loop, right, which doesn't have a range object, right? There's no index that's associated with this. We're just getting each animal stored in the variable animal right here each time this loop runs. So this is very handy, but there are times where it would be nice to actually have an index, right, for each of these as we loop through, but also have, have the thing stored alongside it. And so in order to do this, we can use an enumerate object. Now, to enumerate something means to make a numbered list of something, right? So let's try this. Let's type in enumerate good pets, and you'll see that we get an object, right? Enumerate object at, and then here's the memory address for the object that we just created. And so this is something now that contains a numbered version of this list. And in order to see this, okay, we actually need to enclose this in a list function to convert this to a list. Now, the cool thing about enumerate, okay, as opposed to range, is that it contains the same objects that were in the original list paired with an index in the same order. And so let's just see what this looks like. So we'll type list, and then we'll type enumerate good pets. So basically, we're just wrapping this enumerate object with a list function. And now what you'll see is the following. So what is this? Well, it's a list, right? And it's a list of tuples, right? So the first one is 0, dogs, right? So this tuple, we can reference this, this index by accessing the first thing in the tuple, right? And same here. This birds now has index 1 associated with it, and so forth, right? So we could now iterate through this list by using two variables in our for statement. Because what we could do now, just check this out. This is a little bit mind-blowing at first, but I think it'll make sense if you look closely here. So for index, comma animal in enumerate good pets. Okay, if we type this, then what this will do is index will take the first thing, okay, in the tuple, and animal will take the second thing, which is dogs. Okay, and enumerate always does this. It makes a set of tuples with the index first and whatever was there to begin with in the list second. Okay, so what this does is this is basically index comma animal. This is actually really just a tuple, index comma animal, right? Remember, brackets are optional, but we could actually include them here just for clarity. So we could type for, and we type index in brackets, comma animal, in enumerate good pets. There we go. Okay, and now we can press tab. Now let's print, for each of these, we're going to print index, comma animal. Okay, and now you'll see that we got 0 dogs, 1 birds, 2 cats, right? So this basically went through, right? This went through each tuple in the list, right? And assigned index to the first thing in the tuple and animal to the second thing in the tuple. So so this is handy in many situations when you just need an index for each of the things in a list, right? Because this one doesn't have any indexes in it that we can access through this type of loop, right? For animal and good pets. So this gives us access to both things. It's the best of both worlds in a way. Just remember when you do this that you're going to need 2 variables after the for keyword, because the enumerate object contains both the index and the element. And the order matters, right? So you're always going to put the index first and the element variable second. Okay, next is parallel list data structures. Really just data structures first. A data structure is some sort of useful organization of variables, of data. variables that contain data, really. How you organize your data in a program makes all the difference. And this unit will start with some elementary data structures. Actually, this is the end of our unit, but really, we're going to start with some basic data structures and move toward more sophisticated ones later. So, in general, storing data is a crucial function, right, of many programs, and using unrelated or differently named variables for every single piece of data is mind-bogglingly tedious, if not impossible. So let's start with an example, because that's really where this begins to make sense. Let's create a parallel list of data structures to relate the names and hit points of a group of monsters. All right, so here's our solution. So in our example, each monster has to have a name and associated value to hit points. How can we relate these two things, right? So if we have a goblin, for example, and he's got 12 hit points, how can those things go together, right? Well, we could create a variable goblin and goblin hit points and give it 12. But a much better way to do this is use lists, right, that are ordered, okay, in parallel. So in other words, our first monster, if you look at these two lists here, right, we have a list called monster names. It contains goblin, ogre, dragon in that order. Remember, the orders matter. And then monster hit points contains 12, 52, and 780. So the implication here is that at index 0, we have both properties of the goblin, right? So we could iterate through this list and print each monster and its hit points together, right? So the ogre has 52 and the dragon has 780. So as long as you have these in the same order, then each of these monster names could go with a specific number of hit points down here. So we could then iterate through, right, each of these and say for X in range length of monster names, this would be how many things are in there. We could print the monster names and monster hit points, right? So let's just cut and paste these, and we'll put them right into the terminal. There we go. Both of those will be set, and then we'll cut and paste this as well. And that might actually give us a problem. Yeah, let's just cut the top one. There we go. Cut the top one and press Enter, and then we'll cut this bottom one. Press Tab first, though. Paste that in there, and press Enter. And there you see, right, that what it did is it printed the monster names 0 and monster hit points 0 first, right? So that was goblin and 12, ogre 52, dragon 780, etc. So the key idea here is just to keep things in the same order and use a common index to relate all the things that need to be related. So, here's the key. With access to one item, you can always retrieve the index and use it to look up the corresponding other properties, right? So we could have many other categories here. We could have like strength and magic power and whatever else you want to have here to relate all the things, right? So this system of organization that I'm applying here is what makes this a data structure, right? It's not a structure created by the computer, but by us, right? We're making this to help keep track of things with our own system. And that's the essence of a data structure. Okay, let's look at example 2. Create a parallel list data structure to organize and maintain a set of difficulty levels for guess the number. Okay, the first thing we're going to do here is grab my source code for the extension version of this project. So just click this link here, and you should see this come up, and press Control A, Control C, close that down, and paste that right into your note for 1.7. And this is what we're going to work with here. We're going to update this so that we have a basic parallel data structure here, and this is the area that I want to focus on. Right? If you remember, we learned how to a much better way to enter numerical data like this, which was to use constants. And a good way to organize your constants is with lists, right? So before we knew how to work with lists, we just kind of set these things depending on the difficulty level that was selected up here. And because if they select easy, then right, the range max is going to be 20. So they had the secret number was between 1 and 20, right? And you got 6 guesses. But if they selected difficulty 2, right, it was between 1 and 30, and there were 5 guesses, right? And of course, from 1 to 40 meant from 1 to 40 on hard meant 4 guesses. Right, so I'll show you how this works reasonably well, but of course I'll show you how to do this and organize this in a better way. So let's start by first of all creating some difficulty constants. So what I'm going to do first is we're going to go right up here and we're going to add some space, and we'll type easy equals 0, medium equals 1, and hard equals 2. And oops, I typed ease. Let's make that easy. There we go. Okay, so now after this, what I want to show you is we're gonna create a list of the different range maximums that correspond to these 3 indexes, 0, 1, and 2. And we're going to use these constants later to refer to specific difficulties. So in other words, range max, we'll type range max equals, and now we'll enter our 3 numbers, 20, 30, and 40. 20, 30, and 40. And now let's enter our guesses, right? So we'll organize our data. Our guesses are going to go down by 1 every time, right? 6, 5, 4. So that's easy, medium, hard. Again, here range max is easy, medium, hard. And then the cool thing is, if we wanted to say if we wanted to call up this number here, 30, right? But we know that that's actually medium, right? That's our medium one because that's in the middle, right? So we could reference this by typing range max and then bracket and then medium. And the nice thing is here that, right, we don't actually need to know the index of medium because we stored it up here. Right, so you can literally just type meaningful variable names to call up the appropriate range max on medium. Or we could replace this with hard. And now, right, this would return the value of range max 0, well actually 2, which is 0, 1, 2, right there, 40. And so forth, right? Guesses easy would give us 6. Right, because easy has index 0. So this is a really nice way to store information if you're going to use a parallel structure, and I recommend using these as well if you want to refer to specific indices based on some concept, right? Some sort of organization system like this. Now, we don't actually need these for now, but what we're going to do next is go ahead and update our program to use these lists instead of, right, these random mystery numbers out here. And we'll start by looking at line 21. So this here, line 21, we set the difficulty by, right, asking the user to type in input from 1 to 3, right? And so this is not validated, but presuming that the user does type 1, 2, or 3, what we could do is make this difficulty, right, actually correspond with the indexes that we chose for each of these difficulties. So if they type 1 in, that should be easy. 2 should be medium. 3 should be hard, right? So, but we really want to have 0 in here if they type easy, if they type 1. So what could we do? Well, of course, we could just subtract 1 from this value, right? Because they type 3, then we want our difficulty to have index 2, which is hard, right? So let's just subtract 1 minus 1. And now we know that once the difficulty is entered by the user, we can then use this variable, right, difficulty, to reference the appropriate position on the list for each of these variables. Now what's really cool here is we don't need any of this any longer, right? Because we could now just refer to these by index using difficulty in each place. So you can delete all that stuff. Now on line 23, right, we have this range max, which is being highlighted here. It's saying, I don't know what this is, right? Well, of course, we've changed this to a constant that has a list of stuff in it. By the way, you could also use a tuple here, right? You could use a tuple here to show that these will never change. And that would be absolutely valid as well. Okay, so really, here we want the range, the top end range max for our current difficulty level, which is stored in this difficulty variable. So we can use range max, our constant that we made, and we'll tell it index difficulty, right? Difficulty. Because if they typed 2, then that means that difficulty is hard, and we're going to get index 2, which is 40, right? The next thing we need to change is line 26, right? Guesses. Because we change that, again, we change that to a constant list as well. So let's change this to guesses. And then, again, we'll just type in difficulty, because that is going to have the right index, whatever was entered, -1. And, of course, we need to add that here as well. So guesses difficulty. I'm going to cut and paste that into the right place there. All right, do we have any more places? Right here, we have one, right? So let's paste that in there as well. So now each of these times, right, we're referencing guesses difficulty, which has the right noun of guesses, right? Either 6, 5, or 4, depending on what was typed. Okay, and so this is the idea here, right? Is now we've solved 2 problems. First of all, we've got our mystery numbers up and away into a meaningful place, right? So we've got a constants block here. And we've got less code overall, right? Because we've stored all these things in lists, and we didn't need all these if blocks that we had in here, right? So this is much more efficient and much more organized. This is one way that you can effectively use a parallel list data structure. Okay, so this brings us to sequential list data structures, which are way better than parallel structures, although sometimes you use them both in tandem. So a sequential data structure is another elementary data structure, which involves placing items in a list in a specific order, okay, and then storing copies of that list inside a master list, a 2D list. So this data structure does require knowledge and the ability to work with and create 2D lists. So example 3 says use a sequential list data structure to input, store, and print the last name, first name, age, and gender of a number of persons. Okay, so we want to store a bunch of people and their properties in a sequential list data structure. So for each person, we're going to input their information into a list in the following order. And this is a key, right, is to establish the order somehow and write this as a comment right into your code so that it's explicit. You're going to see this down here as we progress. So let's, for the moment here, let's actually just comment all of this out. Control space or control slash, and we'll call this example, example 3. Oops. Sequential list data structure. Okay. So, so if we have all of these things stored right in our list in this order, right, then clearly at index 0 we have last name, then first name, then age, and then gender, right in that order. So we're going to start with our program here with a comment describing this, right? So so what I would do is just type data structure. And I want you guys to do this in your projects, right? In your game that you're going to create, to describe how you're storing your information, and then we'll start with, we'll actually just type the list right here. And we'll type last name, first name, age, and gender. Okay, and those will be the it's I'm kind of using variable names here, but this gives, right, the reader a clear picture of what goes in what order, right? So next, what we're going to do, of course, is create a 2D list, and we'll call this list people, right? Because we're going to be putting a lot of different people in here. Equals, here we go. And we're just going to make this, if you notice, you press enter, you get 2 spaces down, and now you're ready to actually start putting items in here. We're going to make this look really good. We're going to spread this out, and let's add some people to this list so they're here by default. Okay, and we'll start with Tucker, right? So now, of course, we're going last name first, right? Last name, then first name. So really, this is Garrett Tucker. Garrett Tucker, not Trucker. Tucker. There we go. And Garrett. And he's 31, and he is male, capital M. Now we'll put a comma out here, right? Because we're going to add another entry. Each one of these is a list, right? With a specific order according to our data structure. So the next person is Sheena Smith. So we'll type Sheena, or we'll type Smith rather, and then Sheena, and then she'll be 19. She'll be a female, of course. And we'll finish with, of course, Sean Connery. And Celebrity Jeopardy, 71. There we go. And we don't need a comma here. This is the last entry in our 2D list. So there we go. We've got 3 people in our list, and our data is stored last name, first name, age, and gender. Okay, so if we wanted to input more people, we could just use this loop here. We're going to type this out together because it's good to type this stuff, I think. So let's start a while loop. We'll say while, and what we can do is actually just start this with a yes/no question, right? So we can actually take input, while input, add a person, yes or no, right, is well, dot lower, I guess that would help, because then we could type, a capital Y or a regular Y is equal to yes. What we'll do is we'll add some stuff to the list, right? So we can take our last name as input, and we'll type last name. There we go. And we'll take our first name. It's going to be input first name. Okay, and then age equals inputs, age, and finally gender equals inputs, gender. Okay. Now, of course, this age, we need to convert this to an integer. So we'll wrap that in an integer. Looks like I left that out here in my... Oh no, I did put it in my example, so that's fine. And so there we go. We have all 4 things, and now that we have all 4 things, assuming that we're not validating any of this input, we can append this, all this stuff, to our people list. But first, we have to put this stuff into a list, right? So, which we can do right in our append statement. You can see that I've got these square brackets in here, right? So we can type people.append, right? And now inside this, we're going to make a list out of all 4 of these things, and we're going to use the right order, right? We've got to use this order because everything always has to be in the same order. So we're going to append last name, first name, age, and gender, right? And so there, we're appending a list to our list, our people list, and that's putting our person in, right? Our new person. Okay, so this should actually take input, and before we test this, what I want to do is just add something that will print the entry, so we can actually see these guys show up when we're done, right? When we don't type yes. So to print the entries, if we want an index like this 0, 1, 2, what we could do is use the enumerate object, right? Because what enumerate does is for each of these list items, it will give us an index, 0, this, 1, this, 2, this, etc., right? As a tuple. So let's type for index, person, right? So that's a tuple. And then we can type enumerate people, right? And so this will give us a counter that we can print. So then we'll print, and I'm just going to use the format, right? The format version of print here instead of this dot format. But what we want now is, well, we're going to print the index and then a period, right? So we'll do index. There we go, and close bracket, and then dots. And now we can type all this other stuff, right? And what we want to do now, of course, is put the last name, first name, age, and gender next. So how do we do this? Well, remember that as we're looping through all the people, right, each person is going to be stored in this variable person, right? And this is just a list, right? A list with in each case going to have 4 things in it, right? From index 0, 1, 0, 1, 2, and 3. So this is where it would be kind of nice not to use the indexes 0, 1, 2, and 3, but actually just have some index constants that we could refer to in here, right? So let's add those before we continue. We'll pop up here, and I'm going to show you how, of course, you can use multiple assignment for this, which makes it super easy. So we'll just create some constants. We'll say last, comma, first, comma, age, comma, gender, equals 0, comma, 1, comma, 2, comma, 3, right? So there we go. We just got a constant set for each of their respective places, right, for in our data structure. And now we can use these, right, as when we print right here. So we're going to start with last, right, last name. So we want to create another variable that's going in here. So we're going to type person and then, not parents, person, and then last, right? Because that is the first thing. And we'll close that off. And then comma. And then we can type person first, right? Because our first name comes next. And close off our squiggly bracket. Next is the age. So we'll do another one, person, age, oops, capitals, right? Because it's our constant we want. It's the right index. And then finally, the gender. So we want person and gender. There we go. And make sure we have our closing quote and our bracket to finish off that print statement. And that should do it, right? That's actually a much nicer thing that I have here. But this works too. If you want, you could look through this and see how I did this. Using the star, the asterisk, which I talked about before, which prints all the things in the person, right? And that would work fine if we printed our index first, ended with nothing, right? No carriage return, and then printed all the things with this separator, the comma, and the space. Okay, so let's test this and make sure it works. All right, we'll add a person, Rogers, Buck, and he'll be 51, male. Okay, so there we go, right? We see Buck Rogers there added at the end of the list in all his glory. Now, say we wanted to delete one of these. How could we do it? Well, remember that each of these is stored as a list inside people, right? So it's just a matter of getting rid of the right list, right? And so a nice easy way to do that is to just ask which which index to delete. So we'll start with that. So let's say we wanted to delete index 2. Well, we could say ask the user to type an index and then just pop whatever item in people, right, is at that index. So that's pretty easy. Let's just say popnum is equal to int input pop which index, right? And we'll take that as input at the end. And then we can just go people dot popnum, right? And that will get rid of it. And then, of course, let's print this to make sure that that actually happens. And, of course, we should be putting this in a function normally so that we're not copying and pasting our code like this. Perfect candidate for a function. But for now, this is easy enough. It should do the trick. So let's add a person again. And Rogers, Buck, 51, male. No, we could keep adding people, but and we'll say we'll pop Sheena Smith here, number 1. And you can see that she is now gone. Buck Rogers is now at index 2, right? Because it automatically shuffles somebody back, all the other list items back 1. So that works really nice, right? This is a super easy way to manage records, right? When you use a 2D list data structure like this. Very beautiful. Okay, so at this point, we've already talked about index constants a bit. So really, you could go ahead now and work on Replit assignment 1.7a, which actually there is a assignment before project 3, but it goes from A to C, and the project is B and C, which you'll find on the project page. Good luck, and we'll see you later.